Hello everybody. Last class we have discussed about the different types of solid state like crystalline and amorphous solid state, and I told you the next class we will be discussing about the classification of crystalline solids. That means we are focusing upon the crystal character or crystalline solids and what are the different type of crystalline solids we are going to discuss. Here actually based upon the number of particles or especially the type of particles and also based upon the attraction force between the particles, we are classifying the crystalline solids into four categories. That are the what we are going to see now. There first one is molecular solids, covalent or network solids, ionic solids and metallic solids. So these are the four type of category: molecular, ionic, covalent or metallic. These are the four type of crystalline solids. So as I told you, these four categories are purely based upon the type of particles and the attraction force between the particle. All of you know very well, like if the attraction force is different or the type of particles are different, then automatically their nature or their properties like physical property or chemical property or electrical conductivity property, melting point, these all the properties are going to change according to the force of attraction between the particles. So usually for the CBSE exam purpose also, you can face the type of question like for 1 mark type question will be coming from this section. By giving some example, they will be asking you what is the type of this crystalline solid, or they will be asking you what is the type of interaction force in such particle. That type of questions we are used to expect from this category. So let us see in a little brief manner regarding these four type of crystalline solids. So for that purpose, first thing I am going to say about the ionic solids. In the case of ionic solids, you can see the constituent particles. From the term itself, you can understand the constituent particles are positive and negative ions. So definitely you know if they are having positive and negative ions, then the natural force will be strong electrostatic force of attraction. So in such case, here actually I am not given that point. Actually you want to remember one more point, as you know that very well, like when we are considering about their electrical conductivity. In the case of ionic solids, they are usually insulators in solid state but conductors in molten state and in aqueous solutions. That point you have to take care very much. That means if they are in solid form, they are not going to conduct any type of electricity, because there is, you know very well, for a conductor there should be a free or valence electron for the metallic conductors or that type of solid state. So insulators in the solid state, but in the molten form they are very good conductor, because you know in the case of molten form what will happen, they will be converting into positive and negative ions and they are carrying the charges. Hence in the case of molten state, the ionic solids are conducting electricity. That's the one important point you have to remember. And such examples are KCl, potassium chloride, barium sulfate, potassium nitrate or lithium fluoride, etc. And second type of solids are molecular solids. Actually in the case of molecular solids, the definitely you know the constituent particles are, from the term itself you can understand they are molecules. And when we are considering about their attraction force, you have to know another thing. In the case of molecular solids, you are having three type of molecular solids. They are non-polar, polar and hydrogen bonded molecules. Depends upon the nature of force of attraction or nature of particles. Sorry, it will be same only, molecules only, but based upon the nature of attraction force, we are classifying again these molecular solids into non-polar, polar or hydrogen bonded molecules. So in that case, in the case of molecular non-polar solids, the force of attraction will be dispersion or London forces, that you are already learned in last year 11th class. Dispersion or London forces are coming under non-polar molecules, whereas in the case of polar solids there will be dipole-dipole interaction. Dipole interaction means that is the what we can say, two charged particles attraction, two poles. Dipole means two poles only, their interaction force, that is a dipole interaction force. Whereas the third one is already, that is the hydrogen bonded solid. In that case, the force of bonding will be hydrogen bonded solids. So these are the three categories which are coming under molecular solids. So the three categories are, one more time, the three categories are non-polar, polar and hydrogen bonded solids based upon the force of attraction, either van der Waals force or dipole-dipole interaction or hydrogen bonded interactions. So these are the three type of interactions in the molecular solids. And regarding their conductivity property, they are insulator, or they are not conducting any electricity. And examples are carbon dioxide, in the solid carbon dioxide, that already in the 9th class, that is known as the dry ice. Or same way hydrogen chloride, iodine, I2 molecule, ice. These are the examples coming under molecular solids. And the third one we are going to see is about the covalent molecular solids, covalent solids. So in the case of covalent solids, the constituent particles are atoms. Atoms are the constituent particles, and definitely the force of attraction are covalent bonds only. The term itself is explaining that the type of attraction force is covalent bonding. And here actually you have to know one more point. The examples are usually we are used to say is about the diamond and graphite. Carbon 2 allotropes are diamond and graphite, that both are coming under this covalent, or its another name is network solids. We are used to say network solids or covalent solids. That examples, diamond and graphite, are the two important examples coming under this category. Also yesterday I told you silicon dioxide or quartz, silicon carbide. These all are examples coming under covalent type of solids. So here the one important point is that when we are considering about their conductivity property, electrical conductivity property, we are telling means, I told you the two examples are diamond and graphite. So very well, last year we have studied in a detailed manner about how the diamond and graphite is different. Diamond is the hardest material, where graphite is the soft one, and also diamond is a, what we can say, a very good insulator, whereas graphite is a very good conductor. So these two opposing characters are coming under this covalent type example in the case of diamond and graphite. The reason very well, last year you have learned about that. In the case of diamond, the hybridization is sp3 and there is no lone pair or no free electron, that is where they are not conducting. Whereas in the case of graphite, the hybridization is sp2 and there is a lone pair or free electron to conduct electricity. That is why graphite, very well, that is they are using in the electrochemical cells etc. as a conductor. So that's coming under the example of covalent type solid. And the last one is metallic type solid. Metallic type solid means their constituent particles are positive metal ions surrounded by mobile electrons. This is actually, there is one C model theory is there. In that theory, we are used to say that kernels, the positively charged center metal ion is known as kernel. Kernels are surrounded by a sea of electron, mobile sea of electrons. So particles are positively charged center and free electrons. So definitely the force of attraction between the particles are metallic bonding. Metallic bonding is the force of attraction. So usually all the type of metals and their alloys are coming under the category of covalent or metallic solids. So here generally the conductivity will be very high, because metal means they are already, we are told about that they are having free electrons. So because of the free electrons, they will be carrying electricity. That is where they are behaving as very good conductors. So these are the four type of solids coming under crystalline solids. They are the molecular, covalent or network, ionic solids and metallic solids. Under the molecular solids, again you have to remember there are three types: non-polar, polar and hydrogen bonded solids. So these are the 3-4 type of classification coming under crystalline solids. So till now we are classification only learned. First we are learned about what? We are learned about the different type of classification of solid state as crystalline and amorphous state. Second classification today we have learned is about the classification of crystalline solids into 4 category: molecular, covalent, ionic and metallic solids. And so today we are going to close now, and tomorrow we will be seeing about the lattices, crystal lattices and unit cell classifications. Thank you.